Hi folks, Joseph Kursky here with you, wishing you a happy Earth Day. Let's explore 10 linkages between Geographic Information Systems, or GIS, and Earth Day, and environmental education and management. Now, in my view, GIS, Earth Day, and environmental education and management are inextricably linked. How can Earth Day and environmental topics be more effectively taught and learned using GIS? Let's explore 10 ways. First, every environmental issue, from pollution to habitat to biodiversity loss and beyond, has a geographic component. Consider the major environmental issues of our 21st century world. Coastal erosion, air, soil, and water pollution, urbanization, desertification, habitat loss, invasive species, deforestation, just to name a few. Each of these issues occurs somewhere, and usually in multiple locations. Each occurs at specific dates and scales, and sometimes at multiple scales. For example, climate change is a global phenomenon that also impacts local weather and crop yields. Each phenomenon exhibits a spatial pattern in its source and its diffusion. Each affects multiple facets of the human and physical environment. Therefore, the geographic perspective is key to understanding these issues, and GIS, or Geographic Information Systems, provides a rich tool set in which to use the geographic perspective. GIS allows for the multiple variables necessary in environmental studies to be used as map and image layers at multiple scales, able to be analyzed in 2 dimensions and in 3 dimensions. Well, really 4 dimensions when you consider time. Let's examine one environmental issue in more detail to illustrate these points in action: coastal erosion. Now, coastal erosion occurs as a natural process of wave action on coastlines, correct? However, it can be exacerbated by human practices of land use and development, and has caused loss of soil, loss of entire tracts of land, damage to property, degradation of land and water, animal and fish habitat, and loss of human lives. It is not only tied to the practices of human land use near and on coasts, ranging from agriculture to residential and commercial development and the construction of jetties, but also is tied to the underlying soil type, landforms, and climate, as well as to changes in sea level over time. Some of these processes occur on the local scale, right folks? Some occur on a regional scale, and some, such as sea level change, are tied to global scale phenomena. Thus, soil erosion is affected by land use, land cover, elevation, ocean currents, local weather, long-term climate, and other processes. Each of these processes operates differently around the world, differently in local areas, and each is affected by and affects other processes. To understand the interaction of these processes requires, in my view, a firm foundation in the principles of physical geography and cultural geography as well, the geographic perspective or way of seeing the world, and skills in using a geographic information system. The same can be said for thousands of other environmental issues. Environmental studies are enhanced by geographic principles, the geographic perspective, and GIS. Second, not only are environmental studies enhanced by GIS, but conversely, the use of GIS is enhanced by a firm grounding in environmental studies. This grounding provides the framework by which questions can be formulated and problems designed. Asking questions is the first part of scientific inquiry. It forms the basis for knowing what types of environmental data to collect, what data to analyze, and what decisions to make. The GIS does not ask the questions. Rather, it is the user that has a firm foundation in understanding climate, ocean currents, seasons, soils, biomes, pollution, human health, and the past and present environmental legacy of the planet who asks the questions, right folks? The environment has shaped humans, and humans have shaped the environment. Understanding this interaction is fundamental to asking good questions, deep questions, thoughtful questions, and solving problems with GIS.